Hello and good morning everyone. Hello, my name is Jabar Arya Lukananta. So today I'm gonna presenting for my FYP1 project. So for my title is StunQuad, which is mobile-based stunting a screen system using decision tree algorithm. So presented by me, Jabar Arya Lukananta, and my matric number A23CS4011, and with my supervisor, Dr. Aziza Saadon, and this for the link video for my reflection. And for the overview, we have introduction, literature review, requirement analysis, and conclusion. So for the problem background, so the current stunted screening process at the Bangor Hospital and surrounding the patient pause remain ineffective for early stunting identification due to reliance on fragmented. While digital health application and reference software like WHO and have introduced basic road charting, they lack the capacity for multi-factor assessment and longitudinal growth trend analysis, leading to inconsistent growth history and depleted health worker resource. This then this technology gap is exacerbated by a lack of integrated coordination between parent-facing mobile tools and health professional dashboard. And infrastructures in they don't analyze longitudinal growth history, so do not integrate parent-facing mobile tools with health professional dashboard. So for the my project aim is the project aims to develop a mobile-based application, namely StunGuide, for screening the children under 5 years old to classify stunted children. In addition, a web-based dashboard for health workers to review and monitor record will be developed. So for the project objective, to analyze the factor contributing to childhood stunting and elicit the requirement for screening stunted children's system. And the second, to design a screening application with feature to classify and monitor stunted children. And third, to develop a screening application with feature to classify and monitor stunted children. And fourth, to test and evaluate the functionality of screening application. And for the project scope, so for the first project scope is the system developed known as a StunGuard. It's a mobile-based application designed for Android user and supported by a back-end server for classification and data management. And second, the classification model consists of four predator, which is a gender, and then age, weight, and height. Birth weight was not included due to unavailability of records. And then the target variable for the C5.0 decision tree is trained using supervised learning with labeled dataset. And the last, the system provides a screening support only, and the system is restricted to children under 5 years old. So this for the SEIS process for the current system, which is a parent or caregiver, health worker, paper record, and hospital review. And the technology used for this system, I use the IDE is the Android Studio or Visual Studio Code, and then the mobile framework is Flutter with Dart, and then the backend and API is Express.js or Node.js runtime, and the database is MongoDB with MongoDB Compass, and the machine learning is Python. So for the methodology, first is the requirement analysis, and then second design, implementation, testing, and deployment, and the last is maintenance. So for the software hardware, the hardware first the hardware is we're using the Intel i5 AMD Ryzen 5, and the RAM with the RAM minimum is 5 GB and storage 25 GB. For the end user hardware mobile device, this is Android smartphone, and then for the hard worker, which is a standard desktop. And for the category for the software, which is the IDE is Android Visual Studio Code, Flutter with Dart, and then the backend in Express.js, the database MongoDB, and the machine is Python. And this is the use case diagram, which is have three actors, which is a parent and admin, and the last is health worker, and with 5 module. And for the architecture diagram of component, here the component diagram which has the it has a component which is the parent controller and help controller and the component for the admin, and it will connect to every API, every external API, which is with WHO standard, G5 classification, and then the result, it will has a result as well, which we can download the report or export, and then we have the notification as well, and it will connect to our database for the system. And this the interface design. This for the first design is the validate and record, and then the second design is the dashboard stand for standard admin. So for the conclusion, in the conclusion, the initial stage of the standard initiative has effectively laid a robust groundwork for a mobile-based stunting screening system. So the problem has been thoroughly analyzed, the requirement clearly specified, and the system fully designed and documented in accordance with recognized software engineering standard. The objectives set for PSM1 have been met, and a clear plan is in place to implement, test, and evaluate to the next in person tool. Once completed, Standard is expected to provide a practical and data-driven tool that support the early identification of stunting risk and contribute to improve child growth with a target community. So that's all for my presentation for FYP1. Thank you.